So we're going to talk a little bit about circuits. You'll need to remember those schematic diagrams or symbols those circuit symbols that we did on like the very first lesson on Tuesday. So the electrons moving in a circuit slow down. They lose energy or charge as they travel through a resistor. Current is charged past a certain point. Therefore, if the current will decrease as well. The current decreases the electron's attraction to that positive terminal or end. So the resistor converts that energy into other forms of energy depending on the job of that resistor. For example, a radio needs sound and a motor needs motion. From this information, we can conclude that as we increase resistance, the current will decrease. To increase the current, each electron must carry more charge and be given a greater amount of potential energy. The more current that passes through a resistor, the more energy converted by that resistor. For example, a light bulb with more current will put through it will shine brighter. So series circuits are circuits with only one path for the current to flow. The electrons move from the negative end to the positive end through a single pathway. So they're connected in series, like lights in a row. Okay, so I'm just gonna, oh, my smart notebook's not happy here, sorry about that. So it's kind of like a town with only one bridge, right? If disaster strikes, many electrons or cars are going to try to leave town at once. The traffic or current will be slowed by that bridge, that resistor. If the bridge is damaged, the traffic or current would stop completely. If the flow of electricity is interrupted or slowed at any point on the circuit, the electricity movement in the entire circuit will be affected. So here, I'm just going to move these out of the way for a second. This is what a picture of what the light bulbs might look like. Okay, so here we've got our battery and two light bulbs hooked up, and there's one path. Okay, it's going to come out, electrons are going to come out one end and go back to the other. Okay, this is what the schematic diagram would look like, that circuit diagram. So in a series circuit, here we have two cells hooked up, one right after the other in series to form a battery. The long end, remember, is the positive end, the short end is the negative end. So electrons are going to come out here. They've got one, they're going to go through this bulb, then they're going to go through this bulb till they get to that positive end. Now, both bulbs must be working in order for that circuit to be complete. In this case, if one bulb burns out and the electrons try to go through, they won't be able to get to that positive end. They won't have that closed path for the electricity to flow. So in this case, if in a series circuit, if one of the bulbs burns out, neither bulb will light up. So this is like a cheap set of Christmas lights. So sometimes you can get these at the dollar store. These were what we had when I was little and growing up. So that was always my job, was to check the Christmas lights before we put them on the tree every year. So if one light bulb burnt out, none of the strand would light up. So you'd have to take a bulb that you knew worked and change the light bulbs one bulb at a time until your strand of lights lit up. Because if one bulb burnt out, the electricity can't get to the rest. It can't close that path. So no lights are going to work when you find that faulty bulb. So, you know, if you have 50 light bulbs on a strand, you had to change them one at a time until the strand lit up. And if two light bulbs went out, well, it was time to just chuck that strand of Christmas lights out and get a new one. So series circuits have one path for the electricity to flow. Parallel circuit is a circuit in which the current has branches into two or more paths. So there's more than one path for the electricity to flow. So there's more than one pathway for the electrons to move from the negative to the positive end of the terminal. And I'm just going to move this aside here. So this is like a town with several bridges. Again, the traffic is not going to be slowed as much as the cars or the current leaves town during that disaster by various routes. And if one resistor or bridge is damaged, the traffic can continue to flow through the other bridges to get out of town. If the flow of electricity is slowed or interrupted at any one point on the circuit, the electricity can continue to move towards the positive end through other pathways. So this is like overhead lights, so the ones we use in the classroom. If one bulb burns out, the rest continue to produce electricity, or continue to produce light, sorry. The electricity has a closed path. So nature is lazy. Nature will always find the easiest path if given the choice. So if the electrons in a parallel circuit have a choice between a path with a large resistance and one with a small resistance, they'll always choose the path with the smaller resistance. So normally in class, we would do a lab where you hooked up a couple of light bulbs in series. or parallel. And what happens is that then we take, so normally, oops, goodness. Here, the electrons would leave the short end, the negative end, go either through here, this path, or this path, and both back on its way to the positive end, and both bulbs would light up. If we were to say short circuit this by taking a wire and putting it on the either side of the positive and negative terminals, well, the electrons are going to go, hey, this is a really hard path to go through those light bulbs and light up. This is a short path, and it'll actually short circuit. It's got that path of less resistance. It'll actually short circuit, and neither of those bulbs will light up. So here, if I just pop back up to the top for a second, here's my parallel circuit. So again, I have my two batteries, or my two cells. These cells are actually hooked up one right after the other, so they're hooked up in series, but they make a battery together. So the electricity can get out here, and once it gets to here, some of the electrons will go through this bulb, and others will carry on to this bulb, and they'll both eventually make its way back to that positive end of the battery. If one bulb burns out, so this bulb burns out, and these electrons are trying to leave, well, then they can still close a path through this way. So our household wiring is hooked up in parallel, so that if one light bulb goes out in our house, our whole house's lights don't go out, just that one bulb does. So if 3 overhead bulbs are added in parallel to a circuit, several observations can be made. All the bulbs will have the same brightness because the same amount of current flows through each bulb. The resistance is actually lowered with more resistors added in parallel because it allows the current to move faster. But the battery lighting the 3 bulbs will die more quickly because the current is moving out of that battery faster. So again, here's my battery or my cell up here. Electrons are going to move out of the negative end, and they're either going to go through this path, the middle path, or the end path. Okay, and each one of them will head back to that positive end. I've added in, if you remember our schematic diagrams, I've added in a switch here. If I add in a switch here and I open it up, well, these 2 first paths are still going to light, and that switch would only control that 3rd path. It's just, normally we do a lab and you'd have to draw all these just for an example. Okay, that's all for today. I hope that helps, and have a great day.